right, so 4.1 angles and their measures. So the first step that we're doing is converting from DMS, which is degrees, minutes, seconds, to decimal. So DMS to decimal. Number 2, we've got 35 degrees, 24 minutes. So if it's just got the one little like tick mark on it, then that's minutes. If it's like looks like a little quotation mark, so there's 2 of them, that's seconds. So the degrees, obviously that part is fine. We just have to convert the like minutes and seconds have to be converted. So to do that, what we end up with is 35, because that's the original, plus what we do is we take this number and we divide it by 60, so this will be 24 over 60, which converts that part into degrees essentially. And so 24 over 60 is 0.4, so this is going to be 35.4 degrees. And so now that is in decimal form there. Grab my calculator so I don't. All right, number 4 is 48 degrees, 30 minutes, 36 seconds. So this one's obviously got a little bit more to it because we also have the seconds part. So we have 48 plus 30 out of 60 for the minutes, and then plus 36 seconds. So to do that, I would need to convert that to minutes, and then minutes, basically, like, then I would take it and divide it again. Or we can just do 36 divided by 3600, just like how many seconds are in an hour, essentially. These conversions are just like, when it says minutes and seconds, it's just like how many of those are in an hour. So we can do 36 out of 3600. If you wanted to do it the other way, you'd have to convert it to minutes first by doing 36 over 60, and then you would have to do it, whatever that number is, over 60 again. So it's easier just to do it this way. So we would get 30 over 60 is obviously just a half, so 36 over 3600. Nope, not multiply, divide. So this is going to end up being 48.51 degrees, and that is in decimal form. Any questions about going that direction? All right, so then the other direction is decimal to DMS. None of these are really hard. They're just kind of, I don't know, tedious, time-consuming, all the things. Number 6 is 49.7 degrees. So basically, we're given, obviously, decimal form. So I need to take this 0.7. Nothing happens to the 49, like the whole number in front. I need to take this 0.7 and convert it into minutes and or seconds, depending on the situation. So this one is just going to be going to minutes. So we're going to take the 0.7, and that now gets multiplied by 60. So just for reference, that's in degrees at the moment. So when I multiply, I'm multiplying by 60 minutes, which is 1 degree. You don't have to write it that way. I normally will just write times 60. I'm just doing it so that you see the unit cancellations here. So this will give me 42 minutes. Sometimes when you are done with that, there will still be a decimal. It will be like 42 point something. If there's a point something, we take that off and we multiply it again to get seconds. So that's when that happens. So in this case, our answer would be 49 degrees, 42 minutes. 99.37 degrees. So in most cases, if you see two decimal places, it's probably going to have minutes and seconds. That's not always 100% like of the time the case, but a lot of times that is going to be your clue. Like, okay, I'm probably going to have minutes and seconds. So again, the 99 just stays, nothing's happening. So I'm going to take the 0.37 and I'm going to multiply that by the 60 minutes, which gives me 22.2. So that extra 0.2 is going to end up turning into seconds. So I'm going to take the 0.2 and I'm going to multiply it by 60 again, which is going to give me 12. So now I take the 99 from the first part, so it's 99 degrees. I only take the whole number portion of this, so 22 minutes. And then the 12 down here for seconds. And you're probably thinking, why in the world do I need this minutes and seconds method versus just doing it in decimal form? Most of the time, yes, we will just use it in like the decimal form. It's typically the preferred thing. The way that this book is laid out, though, all throughout, even through trig word problems, they will give you things in degrees, minutes, and seconds, and you're going to have to be able to convert. Typically, you're going from DMS to decimal, but it is good to know how to do it the other way because sometimes the way things work out, we need to be able to do it the other way too. So you're not necessarily going to be using it as much in like this sense as you will in application when we get to word problems later on. So just be aware. This is just kind of like getting you ready for what's to come later in the section or in the chapter. Any questions on those conversions? I know that's not a lot of examples, but that's literally all the problems they give us. So, all right. So then jumping down, looking at, why do I have things all out of order? I don't know why I have things out of order. Okay. Not actually jumping very far. I just have things out of order on my paper. Converting from DMS to radians. And we'll also in a minute do degrees, no, radians to degrees as well. So 2 different things that we'll be doing. So on these ones, if I have something like, let's just start with an easy one, number 12, 150 degrees, and I want that in radians. What is my conversion factor for degrees to radians? Should know this from last year.
Something to do with 180, right? Over 180 pi.
Yep, 180 over pi or pi over 180 in this case because I need the degrees to cancel. So it's always pi over 180 or vice versa. So in this case, pi's on top and 180's on the bottom because that's degrees. So degrees are canceling. The pi is symbolizing radians. If you want to write like RAD for radians, you can, but a pi symbol is telling you that it's in radians unless otherwise stated. So the zeros here will cancel top and bottom. 15 over 18 can reduce to 5 over 6. So this is going to be 5 pi over 6, which if you remember your unit circle from last year, you might have just known that without needing to show the conversion, which is why sometimes I skip this stuff, but I figure it's just a good refresher for you to have it until we go back over the unit circle. Now, obviously this says DMS to radians. That would imply that some of the problems are going to have minutes and seconds as well. So let's look at well, let's look at 14 first. 11.83 degrees. So if they give us one like this, that's obviously not something that's going to break down like in the last one. I could just reduce it to 5 pi over 6. But since that's a decimal, it's going to be really hard to do that. So when you type this into your calculator, you can just do 11.83 times pi and then divide it by 180. Now what's going to happen is it's going to give you a decimal number, and it's going to just be like 0.206. Because this one doesn't have a pi symbol, you need to write radians to symbolize what it's in. Okay, I realize you may know, but when you get to other problems in the future, you might be looking at it like, was this radians, was this degrees? I don't remember, and you have to go back, so always write the units on there if it doesn't have a pi symbol on it. Questions about that?
Would we be allowed to plug into the calculator 11.83 over 180 and then just add the pi?
Well, you're not adding pi, you're multiplying by pi.
Like,
but yes, you can do it in that order. It's not going to make a difference. Usually I do the whole thing in like one whole, like I don't do it in steps, if that makes sense. But yeah, that's fine. Okay, so now one that's actually in degrees and minutes. 75 degrees, 30 minutes. So this one I need to first take care of converting the minutes into a decimal. So how would I convert this 30 minutes?
over 6.
Yep. So 30 over 60, which is going to give us 0.5. So this is 75.5 degrees. Pi over 180. Which is going to give me 1.32. And again, because it's that, I want to put radians on there because it doesn't just reduce down and have a pi symbol left in it. So just to make it clear what it is, put the units there. All right, now radians to degrees, not significantly different. It's just this conversion is flipped. So 23 pi over 5. And remember, when it's written like this, if you're doing the little conversion chart that I do, the 3 pi goes on top, the 5 goes on the bottom. Some people put the whole thing on top and they end up getting the wrong answer because they don't look at it correctly. So remember, there's no like fractions going in here. Everything is like got its own little spot. So top and bottom here. Now the pi needs to cancel with the pi up here, or pi is obviously representing radians. If they gave us a number that doesn't have a pi in it, then obviously we just need to know radians, and radians need to cancel. So pi's on the bottom now, 180's on the top. So pi's are canceling here. And then you can just multiply. If you can reduce it without having to do that, that's fine too. This ends up giving us 108 degrees, which I actually need to put the little degree symbol on it so that we know what it is. If they gave us one like 24 where it is 1.3, okay, and they've told us in the instructions that we're going from radians to degrees, they didn't write 1.3 radians. I just need to know from the instructions that that was radians. So what I need to do now is, I know that this is in radians, so I need the conversion of 180 over pi, because pi is in radians, so that's going to cancel and leave me with degrees. So I'd have 1.3 times 180 divided by pi, which is going to give me 74.48 degrees. Any questions about the conversions? All right, you might remember from last year, we did arc length and area. I want to say that this book doesn't do a whole lot with area, but we do with arc length. And it should have been in your notes, but the formula for arc length is S equals R theta. What does theta have to be in? Yep. Theta has to be in radians or your answer will not be correct. Okay? Oftentimes, I think y'all found this last year, I will intentionally give you a theta in degrees so that you have to pay attention and convert it. Okay? So make sure that you, ingrain that part in your brain that theta has to be in radians for these problems. So these ones, basically it says use the appropriate arc length formula to find the missing information. The reason they say that, it might have been in your notes, I don't remember, but there's different ways to write arc length. I usually do just this S equals R theta. They have one that's like the theta over 180 to convert it to radians, like within the problem. I usually do radians outside the problem, convert it, and then I plug that number in. It's up to you how you want to do it. It works fine both ways, but these ones will give you some combination of S, R, and theta. They'll give you two of the pieces you're solving for the third piece, so we're not always solving for arc length. So 26. S is what I'm trying to find. R is 1 centimeter. And theta is 70 radians. So theta's already in radians, I'm good. I do need to pay attention to the units that they give us as far as this goes. So S equals R theta. This one's kind of easy. S equals 1 times 70. So S is just equal to 70 centimeters would be my arc length. S equals 2.5 centimeters, so they give that to me this time. R is the unknown value, and theta is pi over 3. They actually write radians, but that should be understood that that's radians. So I start out with S equals R theta. I'm trying to solve for R, so I need to divide S by theta. So R equals S over theta, which is 2.5 divided by pi over 3. Or keep change flip, 2.5 times 3 over pi. Which ends up giving me 2.39 centimeters. So again, I will be looking for units on problems like this, so make sure you pay attention to those. Uh, 30. S equals 4 inches. R equals 7 inches. Theta is what I'm trying to find. How would I set this one up? Or how would I solve for theta? Well, I would start out with S equals R theta. I need to get theta by itself, so I would divide by R. So S over R equals theta, so 4 over 7. And you should probably specify on here radians because there's no pi in there. All right, 32. S is what I'm trying to find. R is 5 feet. and theta is 18 degrees. So I'm going to do this one using the formula that they use in the book in case you want to do it this way. The problem is that theta is in degrees. I need to convert that to radians either using the method of multiplying by pi over 180, or you can use the formula that the book uses, which is S equals R, they do it this way, pi times r times theta over 180 to convert to radians just within the problem. If you want to do it that way, it's fine. You want to do it outside and just plug it in like normal, totally fine too. S equals pi times 5 times 18 over 180. So I end up getting an arc length of 1.57 feet when I do it that way. The other way we could have done it is 18 times pi over 180, gotten pi over 10, and then use that number in there. Gives you the same thing either way. So, however you'd like to do it. All right, just to check, you didn't have any examples in your notes, correct? Okay. All right, this is an example, and then we'll do another word problem out of the book. Find the perimeter of a theta is equal to 60-degree slice of a large 14-inch pizza. It's like a Costco slice of pizza. All right, so just for a visual here, I'm going to draw a little slice of pizza. I guess I could make it a little more accurate since it's 60 degrees. Let me. I like pepperoni, so I'm going to put pepperoni on my pizza. Could also put pineapple on there, but that might cause a problem. All right, so here's my slice of pizza. So I know that this angle here is 60 degrees. May not completely look like it. I know that it is a slice of a large 14-inch pizza. What is 14? Like if you went and you ordered a pizza and they tell you it's a 14-inch pizza, what is that 14 inches telling you? Yeah, the diameter. So what does that mean about this side of the pizza?
7.
It's 7, because I have to cut it in half. So 7 inches is this side and also this side. So I know these sides. What do I need to find to know the perimeter of the whole slice of pizza? Yep, the arc length. Okay. Now, let's see if you remember your unit circle. In radians, what is 60 degrees?
What's 60 pi over 180? My calculator's dead. So
What's 60 over 180?
Oh,
Yeah, pi over 3. So theta is going to be pi over 3. So now I can do S equals R theta. So S equals 7 times pi over 3. Okay. Which ends up being 7.33 inches. So now I have this arc length value, which is this part of the pizza. So now I just add that up. 7.33 plus 7 plus 7 gives me 21.33 inches, which is the perimeter of my slice of pizza. All right, another example, number 36. A 100-degree arc of a circle has a length of 7 centimeters. To the nearest centimeter, what is the radius of the circle? So what information have they given us?
The arc. Yeah.
So S is 7 centimeters. What else? And I could convert that pi over 180. Is that 5 pi over 9? I think. Yeah. So I have that, and I'm trying to find radius then. So S equals R theta. If I'm trying to find R, divide by theta. So R equals 7 over 5 pi over 9, or keep change flip, 7 times 9 over 5 pi. That is not right. There we go. 4.01 centimeters. But notice they said to the nearest centimeter, so I'm going to round that to the whole centimeter of 4 centimeters. Any questions on those word problems? How much time we got? I think we can get the last one. All right, I'm going to do an odd one just because of there's not an even one like it, but there is another odd one that's similar that y'all will do. So, number 45, I'm not going to like write out every little detail of the problem, but I'll write out the important stuff. Kathy races on a bike with 13-inch radius wheels. When her speed is 44 feet per second, how many revolutions per minute are her wheels making? All right, y'all probably know this, but revolutions is like when it makes like one full turn. So we actually do have a conversion factor for that, but a couple little things that I don't think were in your notes that you need to be aware of is 1 radian is equal to 1 radius of arc length, and 2 pi radians is the same as 1 revolution. Okay, so like that would be like a conversion factor there for you, which makes sense because 1 revolution is 1 full time around, and if we looked at our unit circle, 2 pi radians is 1 full time around our unit circle. Okay, so that conversion makes sense. If you forget it, hopefully that will help you to remember. All right, so I know that the radius is 13 inches, and I know that her speed is 44 feet per second, and I want to know revolutions per minute. Now, her radius is given in inches, her speed is given in feet per second. I need everything in the same units, so I'm going to convert my inches to feet so that everything is easier to deal with as far as going to revolutions per minute. So 13 inches converted to feet. Obviously, you don't need to write it out like that, but just for reference, is 1.08 feet. So basically, I'm going to end up with a really big table for this conversion. So I'm just going to go ahead and set this up. So the first thing I know is that her speed is 44 feet per second. So I'm going to start with that. So 44 feet in 1 second. I also know that basically I have 1 radian is the 1.08 feet. So feet are canceling there. I'll wait and cancel all the units at the end. I know this conversion that 1 revolution is 2 pi radians. So 1 revolution is 2 pi radians. And I know that I ultimately want revolutions per minute, so revolutions is on top. So I've got revolutions now. If I started canceling units, I need to get seconds to minutes because I want it in minutes. So I need to multiply or do 60 seconds in 1 minute, like that. So if I cancel units, I've got feet are canceling, seconds cancel, radians cancel, and I'm left with revolutions per minute. We multiply across the top and divide the stuff on the bottom. So when I do that, I have 44 times 60 divided by 1.08 times 2 pi, which is going to give me 389.05 revolutions per minute. So that's how many times her bicycle tires went around in 1 minute. Any questions about that? All right, then your problems, which, like I said, they're expecting y'all to be back around the start of 4th period tomorrow. If for some reason you're not, then you'll just need to do this to turn in for Friday, but I don't know why you wouldn't be back then. I feel like 2 hours is probably more than enough, but your problems are 3, 7, 15, 21, 25, 27, 29, 31, 35, and 47. So the last 2 are word problems. 47 is it's a radial arm saw, but it's going to work the same way as the bike tire. It's asking something about how many teeth, so you just have to pay attention to how many teeth there are based on what it's saying. But the setup's going to be the exact same as the bike tire one.